All right, so let's look at some examples. So here we got a couple examples. So he says, in a company of 40 employees, in a company, the work of 40 employees is supervised by five managers. Five managers are supervising the work of 40 employees. So the question is, what is the ratio of employees to managers? Well, clearly, if there's 40 employees for five managers, we have a ratio of 40 to 1, 40 to 1, 40 to 5. So for every 40 employees, for 40 employees, yes, we got five managers, right? And remember, a ratio can also be written as a 40 over 5, right? But obviously, in the last page, we saw that it said when comparing more than two numbers or numeric quantities, using the colon is preferred. Okay, so here again, we're comparing two quantities, employees to managers, so that's why a colon is preferred. However, we could totally write it like this as well. And some of the rules that apply here also apply here, also apply here. So for instance, we could simplify this. So for instance, what you could notice is that both 40 and 50 are divisible by 5. So 40 goes on 5 8 times, and 5 goes on 5 obviously 1 times. So you're also left with a ratio of 8 over 1, or in this case, we can write it as 8 ratio 1, 8 to 1. So for every 8 employees, there is one manager, or which is to say the same thing for 40 employees, there are five managers. For every eight employees, there is one manager. Okay, good. So that's one thing. Next, a variable cost is 4,000 for sales volume of 24,000. So variable cost, we're going to get pretty intimately acquainted with what variable cost is. You probably already know this from your course in accounting. So variable cost is $4,000 for a sales volume of $24,000. So let's say a company sold $24,000 worth of goods. That's the volume at which the amount of volume at which they sold, and out of that, $4,000 was their variable cost. It was cost that could change from month to month, week to week, year to year. Okay, so the ratio of variable cost to sales volume is 4,000 to 24,000. So for every $4,000 spent on variable costs, they sold $24,000 in sales volume. Okay, so 4,000, 4,000 ratio 24,000. They could have expressed it differently as well. For example, they could express it as, if we cancel out these zeros, we divide 4,000 and 24,000 both by 1,000, then what we are left with is 4 ratio 24. So for every $4 spent on variable costs, for every $4 spent on variable costs, they sold $24 worth of items in sales. Okay, so that's the ratio of variable cost to sales volume in this case. Next, the cost of a product is made up of $30 of material, $12 of direct labor, and $27 overhead. So $30 in material, $12 in direct labor cost, and $27 in overhead. So overhead would be miscellaneous costs in some sense. So cost of the products is $30, right? Direct labor is 12, ratio 12, and it's 27 for overhead, right? So that gives us nice ratios. Remember from the last page, it said that uh, the the when it's frequently done, rates are expressed as ratio turned out to no, not this one. If the terms are in different units, the terms need to be expressed in the same unit of measurement before the unit speak of drop. Obviously, have all in the form of dollars. So, and so we don't have to worry about it. But we can drop them. We don't have to write the dollars every time. They're all in dollars, so we can just say 30 ratio 12 ratio 27. That means, what's the total? 30 plus 12, 40, 42 plus 27, 69. If the $69 is the total cost, then 30 plus 12, 42 plus 27, 69. So that out of the 69, if $69 was being spent on the cost of a product, 30 was going to what? Materials. 12 was going to what? Direct labor. And 27 was going to overhead. Okay? Very good. So that are some examples of ratios. Okay, let's get moving here. So reducing ratios to lowest terms. When ratios are used to express a comparison, they're usually reduced to lowest terms. Okay, so when you're doing some kind of comparison, we reduce them to lowest terms. We'll see some examples. I just did that earlier with the 40 to 50 employee example where I simplified it down to 8 to 1 employees. That's what he's talking about, reducing ratios to lowest terms. This means that the terms of the ratios are integers without a common factor other than 1. So reducing them to lowest term means that the terms of the ratios are integers without a common factor other than 1, which that means is, so let's say I had 40 ratio 5, with 40 employees to 5 managers. If I divide both sides by 5, because they're both common factor is 5, then 5 times 8 is 40, and 5 times 1 is 5. So I have a 8 ratio 1. Now I can't simplify it because they're both, it says right here, integers. So their integers are basically whole numbers, positive and negative whole numbers, including 0. And are integers without a common factor other than 1. So there's nothing else that completely divides 8 and 1 except for 1 itself. So they don't have any other common factor. So that's how this is therefore the lowest terms in which I can write it. Next, he said ratios may be rewritten without changing the original relationship between the quantities using rules similar to the rules we're working with fractions. So right now, what is Zach talking about is like 40 over 5. I could have written it as 8 over 1, same thing, right? So we did, that's why we started this course again with fractions. So thus the procedure used to reduce ratios to lowest terms is the same as that is to reduce fractions to lowest terms. So the procedure used to reduce ratios to lowest terms is the same as that used to reduce fractions to lowest terms. For example, if the cost of products is made of $30, $12 of direct labor, $27, then the respective cost is 30, 12, 27, or in the lowest terms, 10, 4, 9. So in this case, they found a common factor between 30, 12, and 27, which is 3. And then they just reduced that down by 10 to 4 to 9. So if for every 10 plus 4, 9, $10 spent on materials, $4 was spent on labor, and $9 on overhead. In other words, for each $10 in cost of material, there are $4 in direct labor cost and $9 in overhead. However, when a ratio is expressed by an improper fraction that reduces to a whole number, the denominator 1 must be written to indicate that two quantities are being compared. When the ratio is expressed by an improper fraction that reduces to a whole number, the denominator 1 must be written to indicate two quantities are being compared. We'll see the example of this in a second. So let's say reduce each of the following to lowest terms. So let's reduce 80 and 35 to lowest terms. Okay, so here one of the things to kind of remember is 80. I need something brighter than that so you guys can see it properly. Yeah, so 80, 80 ratio 35. So all we have to do is find some common factors. Now I can see that 80 is divisible by 5, and so is 35 divisible by 5. How can I tell? Any number that ends in 0 or 5 is divisible by 5. So 80 goes 16 times on 5. So 5 goes 16 times into 80, and it goes 7 times into 35. So 16 ratio 7. Now I can't further reduce this anymore because there are no other common factors between 16 and 7. I know that because 7 is a prime. Prime numbers are numbers that are only divisible by themselves or 1. So you can only divide 7 by 1 or by itself. Other than that, if you divide it by anything else, you will not get an integer. You will not get a whole number. So what we are left with then is 16 ratio 7. So here he's got the same answer, right? He did that. 5, you see 5 is divisible 16, 7, so 16 and 7, okay? And you can see he can also do it in this form, in the fraction form as well. Now next, the terms of the ratio 48, 30, and 18 contain a common factor. Okay, so this is the example he's doing. So 48, 30, and ratio 18. Again, the common factor we can see here is 3. For sure there's 3, right? And the reason I can tell it that all of them are divisible completely by 3 is because if I add any of their respective digits, so if I add 4 to 8, it's 12. 12 is divisible by 3. 3 times 4 is 12. So that's how I know it's divisible by 3. 3 plus 0 is 3, and 3, that means 3 is divisible by 3, so that's also divisible by 3. And 18, well, I can tell 8 plus 1, 9, and 9 is divisible by 3, so is 18 divisible by 3. So whenever you're testing if something is divisible by 3, all you have to do is add digits. So 3 plus 2, 5, 5 plus 3, 8. 8 is not divisible by 3, so 3, 2, 3 is also not divisible by 3. Okay, so that's the way to make to check if something's divisible by 3. So let's look at that. So here we have 48. So 3 would be go 16 times on it. Then ratio 10 times, ratio 6 times. 6 times 3 is 18, 10 times 3 is... Now we can see that all these new numbers we got are all even numbers, and all even numbers are divisible by 2. So as we know, 2 times 8 is 16, 2 times 8 is 16, so 2 times 5 is 10, and 2 times 3 is 8, 6. So this is now the reduced form of the same form, the terms of the ratios. Now this is in this reduced form, okay? All right, so let's look at the next one. 225 ratio to 45. He's doing the same thing. He's finding that 5 is a he found that 45 is divisible by 225 is divisible by 45, and so is 45 divisible by 45, right? So if you say 45 times 5, 45 times 5, you get 5 times 5, 25. 5 is here, 2 goes on top. 5 times 4, 20, 225. So 45 goes on 225 5 times, and it goes obviously on itself 1 time. So we are left with 45 times 45. 45 times 1, so we're left with 5 ratio 1. 5 ratio 1, right? So it's saying 2 to 5 ratio 45. The common factor is 45, so 45 times 5 is 225, and 40 times 1 is 45. So we write it down like that, right? Or we can write it down like that, whatever. And next, we have 81, 54, and 27. All those are divisible by 3 again, and so that's how he's simplifying them down to their lowest terms. So 81 ratio 54 ratio 27. 81 is divisible by 3. How can I tell? 8 plus 1 is 9. 9 is divisible by 3, so is 81. Therefore, this is a technique you can use to check if something is divisible by 3. You can just add the 2 digits together, or 3 digits, or whatever number of digits, and the answer, if the answer is divisible by 3, then the whole actual number is divisible by 3 as well. So 81, so this goes 27 times. That's 27 times 3 is 81. This is 124. So that's 17 times. Yes. No. Yes. 7. No. 124. 24. 18. So 18 times 3 is 54, and 9 times 3 is 27. Now 3 times 9 is 27. 3 times 6 is 18, and 3 times 3 is 9. Now 3 times 3 is 9, 3 times 2 is 6, 3 times 1 is 3. 1 is 1. So here do we have our answer, right? And as you can see down here, he's got the same answer, but he went directly. Instead of dividing it by 3, he found that a common factor much bigger than 3, which was 27, and then he directly got to this point, where we got to this point after 1, 2, 3 steps, which doesn't matter really, because ultimately that's what we're trying to get at, the lowest form, the most reduced form of our ratio. Okay, very good. So that is good for now for this examples. We'll keep going, we'll keep practicing, so no need to worry if you don't understand everything. All right, equivalent ratios in higher terms. So let's tackle that in the next video.